Hello everyone, I'm He Tong Dai. Today I will give a presentation of Logram. I developed this log parser together with Heng Li, Che Shaochen, my supervisor Wei Yishang, and Peter Chen. Logs are widely used in a lot of software engineering activities. For example, requirement elicitation, failure diagnostics, and program comprehension. Developers insert logging statements in source code, and during the runtime, logging statement will generate log messages. A lot of work focusing on log analysis has been proposed. And log parsing is the first step of log analysis. So what is log parsing? This is a logging statement in the code of a software system. During the runtime, the logging statement will generate raw log messages, which is a line of unstructured text. The goal of log parsing is to extract the static template, dynamic variables, and header information from raw log message to a structured format. In order to ease the pain of developing and maintaining ad hoc log parsing scripts, prior work proposed various approaches for automated log parsing. And LogPy contains a benchmark which thoroughly compared prior approaches for automated log parsing. As the size of logs grows rapidly and the need for low latency log analysis increase, efficiency becomes an important concern for log parsing. So to increase efficiency, we propose Logram which uses Ngram model for log parsing. Here I will introduce the main idea of Logram. There are some log messages from a software system. The tokens in the blue box are the static parts, and the tokens in red box are the dynamic parts. Just like the example, we can see that the appearance of static tokens has a higher number than that of the dynamic token. As the goal of log parsing is to identify whether a token is a static token or a dynamic token, we can use the number of appearances to distinguish dynamic and static tokens. However, a dynamic token can appear frequently in different log events. This is an example. So only depending on the frequency of individual tokens may not be sufficient. But if we consider trigrams instead of individual token, each trigram will only appear once. So we can use Ngram model to limit the appearance of this kind of dynamic token. Then I will introduce the pipeline of Logram. The first step is dictionary setup for Ngrams, and then we will use Ngram to identify static and dynamic tokens. Finally, we can get the log template. I will first introduce dictionary setup step. At the beginning, we need to pre-process the raw logs. A log message often starts with the header part and followed by content part. The header part of logs often follow a common format in the same software system, so we can directly use a predefined regular expression to obtain this part. And then we can get the content part of each log message. After get the content of each log message, we will split the log message into tokens. And then we will combine the tokens to background. We can use the same method to generate the trigram. After that, we will calculate the appearance of each bigram and trigram. And finally, we can get two dictionaries. The key is trigram or bigram, and the value is the corresponding appearance. Then I will introduce the second step, parsing logs with n-gram dictionaries. In the example, we will parse this logline. At first, we need to transfer the log to trigrams and look up the appearance in trigram dictionaries. Then we can find both trigrams may contain dynamic values, since their appearance are only one. After that, we need to transform the candidate trigram to bigram and look up the appearance in bigram dictionary. This bigram contains only static tokens, as the appearance is false. But these two bigrams may contain dynamic tokens, as the appearance is only one. After that, we will find the overlapping token of the candidate bigrams. The overlapping token will be considered as dynamic value, and then we can get the log template. For evaluation, we evaluate Logram with 16 datasets from logPy on 4 aspects: accuracy, efficiency, stabilization, and scalability. First, accuracy. Here we show the average parsing accuracy of Logram and other log parsing tools. The average parsing accuracy for Logram is 0.825, which achieved the best average accuracy among the log parsers. Then efficiency. To measure the efficiency, we record the elapsed time to finish the entire end-to-end parsing process on different log data with varying log sizes. Here we show the results from BGL dataset. The blue line in the image represents the results from Logram. It needs to mention that the x-axis and y-axis grows in log scale, so Logram outperforms other log parsers significantly. And the result shows Logram outperforms the fastest state-of-the-art log parsers in efficiency by 1.8 to 5.1 times. The efficiency of Logram is also stable when increasing the sizes of logs. Then stabilization. This part mainly want to answer this question. Can we generate a dictionary from a small set of log data and correctly parse the rest of the logs without updating the dictionary? Here we show the results from Hadoop. We can see that Logram achieve an over 80% agree ratio with only 10% of data. So we can say Logram achieves stable parsing results using a dictionary generated from a small portion of log data. Finally, scalability. To measure scalability, we migrate Logram to Spark. We evaluate the scalability of Logram on a cluster with 1 master node and 5 worker nodes. And we measure the throughput for parsing each log data with different number of cores to assess scalability. Here we show the results from Windows dataset. The red box are the box plot of throughput. And the result shows Logram achieves near linear scalability without sacrificing parsing accuracy. We also migrate Logram to an online parser. The online parser feeds logs in a streaming manner, and it will use the existing log to build the dictionary and update during the parsing process. We will use the current dictionaries for parse logs. And the parsing results have over 95% agreement ratio to the offline parser. In this presentation, we first introduce what is log parsing. Then we show the pipeline of Logram. We also evaluate our approach on 4 aspects. And it needs to mention that Logram outperforms other log parsers significantly on efficiency. This is my email address, and welcome to ask me any questions.
Hello again. Now we have the third paper in this session. The name of the paper is Logram, Efficient Log Parsing Using N-gram Dictionaries. We have here two authors of this paper. We have Wei-Yi Zhang and Hitong Dai. And now it's time for questions. So please use the chat to ask the authors any questions. In the meantime, I have questions prepared for them. So my first question is about the metrics that you use to measure accuracy and efficiency. Could you please specify which metrics did you use? Because in some sense, accuracy is not so objective in some context. So how can you precisely measure accuracy and efficiency?
Okay. To measure the accuracy, we will manually check the log template generated by our log parser, and we will identify the log template which is correctly parsed, and then we can calculate the parsing accuracy.
Okay.
And for efficiency, we will record the end-to-end parsing time of our log parser. We will use this time to represent the efficiency.
Okay. Another question is about the dictionary that you use in your process. One of the first steps in your process is the use of a dictionary. So I would like to ask in what sense the approach is independent or dependent on this dictionary. I mean, if you choose one dictionary, you are conditioning next steps in your process, or the process is independent of the dictionary that you are using.
Okay, this need to talk about the online edition and offline edition separately. For offline edition, we will use the entire log data for parsing to build the dictionary. But for the online edition, you can see the evaluation for stabilization. We can see that the dictionary is stable when use a small portion of logs. It's already stable.
Okay. Now we have a question from Ivan. He's asking about accuracy and log template. Are you evaluating accuracy relative to some ground truth set of templates, or based on the templates your tool discovered?
Well, while we use the data size from LogPy benchmark, and it have provide the correct log template for the data set they use to measure the parsing accuracy. The benchmark contains the raw logs and the corresponding correct parsed log template.
Okay. And related with this question, I have another one. Is how many templates are you working all together in the proposal? What is the magnitude of the templates?
Okay.
So is the question asking about how many templates that we generate?
Yes. What is the magnitude of the templates? I mean, are you working with one template, two, one, 1,000 templates? What is the magnitude of the work?
I think it really depends on the data set. Like some data sets has a relatively small number of templates. I can't remember which one. I think like some of the templates, some of the data sets has relatively small, like less than 100 templates. Like some of the data sets are relatively large, like hundreds of templates. Yeah.
Okay, thank you.
It varies very significantly.
We have another question from Ivan. He's asking if accuracy is measuring log template accuracy or the mapping of log statements to log templates.
No, it's is by every line. So every line of log, we have a template, and we want to say whether this line of log is correctly parsed or not. So if you have 2,000 log lines, for each of them we say this is right or wrong, right? Then we use that to calculate the accuracy. So it's based on number of lines of log, like how many number of lines of log that we correctly parsed.
Okay. And my question is about your next steps, because maybe this work is just a first step in a long way. So what are your next steps?
Sorry, can you pardon
Yes,
your
what is your future work? So you have this proposal, and what are you going to do in the next future?
Okay, so I can answer that. So basically, so you can see. So since we only have 10 minutes, right? So one of very critical part of for this approach is that we actually need to automatically decide a threshold to determine whether it's dynamic or static. Right? So, but that context may be really influenced by your characteristics of your logs. Like some of the log data you need a large threshold. Some of the log data you need a smaller threshold, right? So we actually have like a follow-up work. So we use like entropy to basically make a threshold that's irrelevant, that is relevant from the appearance of logs. And so
Okay.
basically a more robust version of this.
We have more comments from the attendees. Ivan said that okay, he got it, so it's the mapping.
Yeah.
And we have another question from Mauricio. He's asking about how many data points do you need before you are able to accurately invert the template? By you, he means the tool.
Okay, so I think this is a similar question as before. So if you are using an offline parsing, right? So if you're using an offline parsing, you have all the logs. So you have all your logs to make a template, then to make a dictionary, then you parse it, right? So second, if you use an online parser, basically that means you see a small amount of dictionaries, then you start to progress. So for the rest, you don't need to keep updating your dictionary. So in that case, you can refer to like the second part of our evaluation, basically the stability, right? So in the stability, basically a lot of the logs, you see very small portion of the logs, like 10% of the logs. You can already build a template that's good for the rest. Right?
Okay, so I think it's time to finish this session for this paper. So you receive a very interesting virtual class from all the attendees here, and you have a very excellent work. So we see you in the next paper. Bye bye, and thank you very much.
Thank you.
Thank you.
My name is